We like to believe humanity is the starting point, the first species to unlock nuclear fire, reshape the climate, and build machines capable of altering an entire planet. But what if that belief is wrong? Deep in ancient rock, in layers of ice, and in sediments older than any civilization, there are clues that don't fit our story. Metal spheres forged in impossible heat, sudden carbon jumps frozen in prehistoric air, and faint traces of radiation long before humans existed. These mysteries connect to a provocative scientific experiment known as the Silurian Hypothesis, proposed by NASA's Gavin Schmidt and astrophysicist Adam Frank. It asks a simple but unsettling question. If Earth has seen civilizations come and go before us, what does that say about our odds of survival? If you are interested, subscribe and be part of the search as we uncover the world, signals and stories written across the universe. Our exploration of Earth's hidden past doesn't begin with ruins or monoliths. It doesn't start with lost temples or with the skeletons of giants. Instead, it starts with something so small, so ordinary looking, that most people would overlook it without a second thought. Tiny metallic spheres, some no larger than a grain of sand, others light enough to balance on a fingertip, and yet these insignificant objects may carry one of the most unsettling questions we can ask. Are we truly the first advanced civilization on Earth? To understand why these spheres matter, we have to revisit something we know very well: the geological fingerprints left behind by our own technology. When humans detonated the first nuclear weapons in the 1940s and 1950s, the aftermath was studied with extraordinary detail. Scientists documented the shock waves, the fallout, the radiation patterns. But beyond the obvious destruction, they noticed something odd. The blast had created microspherules, tiny glass-like beads formed when soil, stone, and metal were vaporized by extreme heat and then cooled mid-air. These beads were small, uniform and durable, the kind of signatures that could survive long after everything else decayed. It became clear that even if every human structure crumbled, these melted droplets would linger for millions of years. They are one of the few signs of our presence that deep time cannot easily erase. If some future civilization dug into layers formed during our era, long after every city had disappeared, these microspherules would still be there. Silent but unmistakable evidence that someone here learned how to harness destructive energy. And this is where the mystery deepens. Nearly identical spheres have been found in rock layers that are far older than humanity, sometimes older than complex life itself. The most famous examples, the Klerksdorp spheres of South Africa. While miners were cutting into ancient deposits of a soft rock called pyrophyllite, they encountered hundreds of peculiar metallic spheres. Some are almost perfectly round. Others have subtle grooves circling around them, as though shaped on a lathe. Their composition varies, often hematite or other iron-rich minerals. But what matters is the age of the rock that encased them, over 3 billion years old. Think about that timescale for a moment. 3 billion years ago, there were no dinosaurs, no plants, no insects. The Earth was dominated by simple microbial life, with nothing remotely capable of sophisticated engineering. And yet, within that unimaginably ancient stone are objects that look, at first glance, as if they were manufactured. Mainstream geologists offer a straightforward explanation. These spheres are natural concretions. Under specific conditions, minerals can accumulate around a central point and slowly form smooth, round shapes. Grooves can form through natural layering or through erosion. On paper, it's perfectly plausible. But physical examples complicate that neat answer. Some spheres are balanced so precisely that they can roll with remarkable stability across flat surfaces. Some show symmetry that natural processes struggle to achieve. Photographs taken over the years show grooves that appear intentional, curved with consistent spacing. While geologists insist these features can be natural, The visual resemblance to manufactured objects is difficult to ignore. It's no wonder these spheres have sparked decades of debate. And they aren't alone. Metallic microspherules have been discovered in geological layers around the world. Some date back tens of millions of years, others hundreds. When their chemical compositions are analysed, many appear ordinary and natural, but a subset displays unusual ratios of nickel, chromium and iron, combinations that look more like byproducts of high-temperature metallurgy or artificial processes than like volcanic ejecta. Natural events like meteor impacts can produce metallic droplets, yes, but those spheres tend to show wide variation in size and composition. The ones found in these ancient layers, however, are often too consistent, almost as if they were mass-produced. Even stranger, some layers rich in these spheres appear exactly at the boundaries of extinction events. Entire ecosystems disappear, and right there in the same thin band of rock is a sprinkling of metallic beads and shock-altered material. Traditional explanations point to asteroid impacts or massive volcanic eruptions, and those certainly can create microspherules. But when the chemical signatures don't match known natural processes, the question becomes harder to dismiss. Could at least some of these layers represent not natural catastrophes, but technological ones? It's speculative, yes, and any such claim demands caution. Extraordinary ideas require extraordinary proof, but the symmetry is hard to ignore. If an advanced civilization lived millions of years ago and destroyed itself in a nuclear conflict or an uncontrolled industrial disaster, the geological record would capture that event in very similar ways. Scattered microspherules, isotope anomalies, sudden ecological collapse. We can imagine an example from our own world. Suppose humanity vanished tomorrow. Our buildings, satellites and machines would crumble quickly on geological timescales, but a thin global layer of microspherules, from nuclear tests, industrial furnaces, metal vaporization, and energy-intensive processes, would persist long after everything else decayed. Future scientists encountering these spheres would know something intelligent existed here, even if they never found a single piece of technology. So when we look backward, into rock formed millions or billions of years before humans, and we find spheres that mirror what our own age will leave behind, we have to at least consider the possibility that we're not looking at coincidence. Maybe they are natural phenomena we don't fully understand. Nature is capable of producing oddities that appear engineered, but not all the samples fit neatly into existing categories, and not all the chemical signatures match volcanic or meteoritic origins. These spheres, tiny, easy to dismiss, may be among the most durable echoes of a forgotten chapter in Earth's history. And they are only the first clue, because when you follow their trail deeper into the geologic and biological record, you begin to see something else just as strange. Patterns in evolution that don't unfold smoothly, but instead leap forward, pause, crash, and restart. Cycles that look almost like someone hit fast forward, or reset. If an advanced civilization once walked the Earth before us, its last traces may not be found only in metallic beads, but in the sudden rhythms of evolution itself, in the abrupt changes preserved in the fossil record. We often hear that the fossil record is like a long, ancient book, an unbroken story etched into stone. But when you actually flip through the pages of that book, you quickly realize how fragmented it is. Entire chapters are missing. Whole paragraphs have been torn out. The story jumps, not in gentle steps, but in abrupt leaps and dramatic pivots. What survives is only a tiny fraction of everything that ever lived, and even that fraction feels strangely uneven. The deeper you go into Earth's history, the more the patterns begin to stand out. Evolution does not always behave the way our textbooks suggest. Sometimes it moves slowly, in small, predictable shifts. But other times, it accelerates with unbelievable speed. It darts forward, stops, reverses, then suddenly surges again. And in those surges, in those strange accelerations, we find some of the biggest mysteries in the history of life. The most dramatic of these is the Cambrian explosion. Roughly 540 million years ago, Earth was home to simple life. Little more than microbial mats, small worm-like organisms, and a few soft-bodied creatures drifting through the oceans. Then, almost instantly on a geological scale, something changed. Animals with hard shells, segmented limbs, complex eyes, and intricate body structures appeared everywhere. They didn't slowly develop over hundreds of millions of years. They arrived quickly in fully formed groups with no clear transitional ancestors behind them. Dozens of major animal groups, phyla, emerged within a window of just a few million years. On human timescales, that's equivalent to an empty field suddenly giving way to an entire cityscape, complete with skyscrapers, roads, and people, all appearing in one burst. Scientists have offered theories. Maybe fossilization improved, maybe oxygen levels rose, maybe genetic systems crossed a threshold that allowed rapid diversification. All of these explanations may hold pieces of the truth, but none fully explain the sheer rapidity, the almost explosive abundance of new forms that appear so suddenly. Even Darwin himself admitted the Cambrian posed a serious challenge to the gradualist view of evolution, and the Cambrian is only the beginning. Throughout the fossil record, we see this theme repeat. Long periods of relative stability abruptly interrupted by bursts of innovation. Look at what happened after the dinosaurs disappeared. For over 150 million years, mammals were small, mostly nocturnal, and overshadowed by gigantic reptiles. Then, after the dinosaurs vanished, mammals suddenly diversified at almost unbelievable speed. Within a relatively short time, they produced everything from massive herbivores to agile predators to primates capable of tool use. The pattern doesn't look like gentle branching. It looks like a door suddenly opened and life rushed through it. Or consider flowering plants. Their arrival is so abrupt and so puzzling that Darwin called it an abominable mystery. The fossil record shows them appearing rapidly and then taking over ecosystems worldwide. Again, transitions are scarce. The gap between before and after feels too large, too abrupt, as if something accelerated their development. Even the story of humanity carries this strange signature. The hominin brain roughly tripled in size within a few million years. A blink of time compared to most evolutionary shifts. Why? How? Climate pressures, social complexity, dietary changes. These explanations circle around the mystery, but none truly settles it. Now, nothing here proves anything extraordinary. Evolution is influenced by countless variables: climate, competition, mutation rates, ecological disruptions, and pure chance. The fossil record is notoriously incomplete. Soft-bodied organisms rarely fossilize at all, and many environments leave no fossils behind. So naturally, the story we reconstruct looks jumpy. But patterns matter, and the patterns we see, sudden leaps, long silences, abrupt turnovers, mirror something else in Earth's history, the rhythm of collapse and renewal. Extinctions are the punctuation marks in life's story. 5 times the planet has lost most of its species in a short window. The worst, the Permian Triassic extinction, eliminated roughly 90% of life. Others wiped out more than half. After each collapse came a period of rapid rebuilding, as if the slate had been wiped clean and evolution was starting over. We attribute these die-offs to asteroids, supervolcanoes, methane releases, shifts in ocean chemistry. Many times that is undoubtedly true, but not every extinction has a clear cause. Some events lack a crater, some lack volcanic signatures, some show ecological upheaval without a definitive trigger. Imagine for a moment that a technological civilization existed long before us. If it collapsed, through climate manipulation, runaway chemistry, nuclear conflict, resource exhaustion, then millions of years later, the extinction it caused would look almost identical to a natural one. A future paleontologist might see a sudden loss of species, unusual chemical signatures, and rapid ecological turnover, but without surviving artifacts, they would have no way of knowing intelligence was involved. This is not a claim that ancient civilizations existed. It's a simple recognition that the footprint of a collapse looks eerily similar to certain mysterious events in the fossil record. Another strange feature of the record is the presence of long gaps, intervals where fossil evidence becomes sporadic or disappears entirely. Traditionally, these are blamed on poor preservation. Maybe the rocks eroded. Maybe they never formed. And often, that's true. But in some cases, the timing is suspicious, happening right after unusual environmental disruptions. If a civilization imploded and dragged ecosystems down with it, fossilization might temporarily drop, creating a barren stretch in the geological story. Genetic evidence also shows that Earth's life has passed through several bottlenecks, periods when species were reduced to tiny remnant populations. These events are usually explained by natural disasters, but they could just as easily follow technological catastrophes. If advanced life destabilized the climate or poisoned the biosphere, surviving species might dwindle to a sliver before slowly rebounding. When you zoom out far enough, the fossil record begins to look less like a smooth evolutionary arc and more like a repeating cycle. Flourishing, crisis, collapse, rebirth. It's a rhythm that mirrors the rise and fall of civilizations in human history, only stretched across millions of years instead of centuries. If intelligence is something life attempts more than once, a recurring expression of complexity, then these resets in the fossil record might be showing us not just biological restarts, but technological ones too. Not direct evidence, but the faint outlines of stories erased by time. Mainstream science, of course, approaches these ideas cautiously, and it should. Without physical artifacts, the default explanations must remain natural. But even with natural explanations, the similarities between past upheavals and the kind of disruption a civilization can create are difficult to ignore. If humanity vanished tomorrow, what would the fossil record show millions of years from now? It would reveal an abrupt disappearance of large animals, a sudden shift in atmospheric chemistry, an unusual concentration of synthetic pollutants, and a sharp drop in biodiversity followed by a rapid rebound. Nothing in that pattern would shout civilization. It would simply look like another mysterious collapse with an oddly fast recovery. In other words, future scientists might see our extinction exactly the way we see extinctions of the ancient past, as a strange, sharp turning point with causes that are difficult to pinpoint. And if that's true, then it raises a final question. How many times has this happened before? To search for answers, we have to look beyond fossils. We need to examine the very air ancient life breathed, because in the atmosphere, preserved in ice and sediment, lie chemical clues of events so strange they could very well be fingerprints of civilizations we've never met. And that's where our investigation leads next. If rocks preserve the scars of ancient fire, then the atmosphere preserves the memories of ancient worlds. And unlike fossils or stones, the atmosphere does not care about species, civilizations, or time. It simply records whatever happens up above, layer after layer, quietly storing its history in the snow and ice that fall at the poles. For scientists, drilling into the deep ice sheets of Antarctica or Greenland is the closest thing to time travel we have. Each pocket of ancient air trapped in those frozen layers is a direct sample of the sky as it once was, untouched, unaltered, and perfectly preserved. Through these ice cores we've reconstructed hundreds of thousands of years of Earth's climate, and for the most part the story they tell matches what we expect. the slow rhythm of ice ages advancing and retreating, carbon dioxide rising when the world warms and falling when it cools, methane drifting upward during wet periods and sinking during dry ones. These are the natural breaths of a living planet. They form patterns so familiar and consistent that scientists can identify eras by the shapes of their curves alone, but not every layer fits the pattern. Here and there, scattered through the cores, are moments when the atmosphere seems to behave strangely, moments when carbon dioxide surges upward far faster than the typical pace of natural cycles, or when methane levels spike so sharply that no known natural source seems adequate. Sometimes these jumps level off abruptly, almost as if some external force drove them upward and then vanished. And in a few rare layers, researchers have detected faint traces of compounds that do not belong in a world without industry. The official line is that these are probably modern contaminants, chemicals introduced during drilling, storage, or analysis, and maybe they are. But there are a few samples where contamination seems improbably unlikely, leaving us with anomalies that stubbornly refuse to fit cleanly into any known natural category. This is where the Silurian hypothesis becomes more than an abstract idea. It becomes a lens, a way of asking not did ancient civilizations exist, but if they did, what would their atmospheric traces look like millions of years later? Because we already know what our atmospheric signature looks like. We're living through it. In just a few centuries, human industry has pushed carbon dioxide levels higher and faster than any increase seen in hundreds of thousands of years. Methane has risen in lockstep, driven partly by agriculture, partly by fossil fuels, partly by changes in land use. Synthetic chemicals, refrigerants, pollutants, and long-lived industrial gases now drift through the sky in tiny concentrations. If humanity were to disappear tomorrow, if every machine fell silent, if every city emptied, the atmosphere would carry the marks of our existence for a staggeringly long time. At first, those marks would look like violence. Carbon would remain elevated long after our last breath, a stark imprint of rapid planetary warming. Methane would take decades or centuries to fade. Synthetic compounds would persist for hundreds or thousands of years, slowly breaking down but never fully vanishing. The oxygen balance would shift as forests collapsed or slowly recovered. And in the sediments forming across the globe, isotopic signatures from fossil fuel burning would settle into layers that future scientists could easily detect. To someone studying the planet millions of years from now, long after all physical evidence of our civilization had vanished, the atmosphere would still whisper of an age when something intelligent altered the sky faster than any volcano or ice age ever could. They wouldn't see skyscrapers or satellites. They wouldn't know our stories, our wars, our inventions. But they would know something happened, something sudden, intense, and deeply unnatural. So when we travel backward in time and find strange atmospheric jumps locked into ancient ice, the resemblance is unsettling. The Paleocene-Eocene thermal maximum is perhaps the clearest example. Occurring roughly 55 million years ago, it was a time when the planet abruptly warmed by several degrees. Oceans became more acidic, deep-sea creatures vanished, and ecosystems all over the world were disrupted. And the carbon isotope ratios from that era suggest enormous amounts of ancient carbon, the kind stored in fossil fuels, were suddenly released into the atmosphere. It is one of the closest analogues to modern climate change found anywhere in Earth's past. Scientists debate the cause. Massive volcanic eruptions are one possibility, though the evidence is inconsistent. Another theory suggests that a huge amount of methane, a gas far more potent than CO2, was suddenly released from ocean sediments. That could explain the rapid warming, but the scale of the event strains existing models. Some researchers have even suggested that a comet impact might have triggered the release, though evidence for that remains sparse. What makes the event remarkable is not that it happened, but that it happened with such speed and intensity. It bears an uncanny resemblance to the greenhouse spike we are generating right now, so much so that some climate scientists study the Paleocene-Eocene thermal maximum, specifically to better understand where our own trajectory may lead. Again, no one claims an ancient civilization caused it, but the fact that the atmosphere can record something that looks so much like industrial warming, yet may be entirely natural, shows how easily the geological record can blur the line between artificial and natural causes. And the ice cores contain other mysteries too. Some layers show traces of heavy metals or chemical patterns that don't match wildfires, volcanoes, or typical natural processes. Isotopic shifts occur that defy straightforward explanations. Methane spikes appear without clear environmental triggers. Usually scientists choose the most conservative interpretation, attributing anomalies to rare natural events or chemical reactions that aren't fully understood. But the more anomalies we catalogue, the more complicated the picture becomes. Consider how subtle the traces of a civilization might be. Geology is merciless. It erases buildings, roads, tools, electronics, everything but the most robust chemical signatures. If an advanced species industrialized for a few thousand years, a mere blink in geological time, then vanished, the only surviving evidence might be a short-lived atmospheric disturbance preserved in ice and sediments. That disturbance might show up as a sudden pulse of carbon, a peculiar shift in methane, a few strange compounds out of place, and then a long return to equilibrium. To a future scientist, the cause would be unclear. It might look like a natural warming event followed by recovery. It might look like an abrupt die-off and then a rebound. It might look, in other words, exactly like the mysterious atmospheric spikes we see in certain ancient layers today. And that is what makes these clues so haunting. The atmosphere records events faithfully, but it doesn't label them. It tells us what happened, not who caused it. If others altered the sky long before us, the evidence would look almost identical to the traces we ourselves are leaving right now. Carbon rising too quickly, methane jumping out of rhythm, chemical fingerprints that shouldn't be there. The sky carries secrets that fossils cannot hold, and the ice remembers what the rocks forget. And as we peel back those frozen layers, the question grows harder to ignore. Have we really been alone in shaping this planet? Or are we just the first to notice the scars left behind? To go deeper, we must turn from the air to the Earth itself, to rocks that contain something far stranger than carbon or methane. Rocks that preserve the fingerprints of energies so powerful, so precise, that nature almost never produces them. In 1972, deep within the equatorial forests of Gabon in West Africa, miners at a uranium site called Uklo made a discovery that stunned the scientific world. It wasn't a strange artifact, or a fossil, or a metal sphere this time. It was something far more subtle, something hidden in the ratios of isotopes within the rock itself. At first glance, the uranium ore looked ordinary, but when scientists analysed it more closely, they found that some of it was missing a particular isotope, uranium-235. A significant portion had already undergone fission. That shouldn't have been possible. Uranium ore isn't supposed to burn on its own. A nuclear chain reaction requires extremely specific conditions: the right concentration of uranium, a precise amount of water acting as a neutron moderator, and a geometry that allows the process to self-sustain. Without technological intervention, it seemed impossible, and yet the evidence was undeniable. The uranium at Oklo had experienced sustained chain reactions nearly 2 billion years ago. The scientific community eventually reached a remarkable conclusion. Under just the right geological circumstances, nature had created its own nuclear reactors. A quirk of groundwater, mineral alignment, and isotope ratios had produced the perfect environment for fission. For hundreds of thousands of years, these natural reactors had flickered on and off, slowly altering the uranium around them. The isotopic fingerprints remained frozen in time. This discovery proved something important. Nuclear signatures can survive for billions of years. Even after every feature of the original environment eroded away, the isotopic scars remained sharp and recognizable. Oklo became a reminder that the Earth itself can, on extraordinarily rare occasions, produce nuclear events. But it also revealed how unmistakable nuclear processes are in the geological record. And once you understand how those signatures appear, you start noticing odd echoes elsewhere. Places where the isotopic fingerprints don't line up with either natural reactors or with typical geological processes. In several uranium deposits around the world, scientists have found isotope ratios that don't match the natural patterns observed at Oklo. The deviations are small, but puzzling. Some samples show unusual quantities of isotopes associated with rapid, intense fission events, the sort of isotopes most commonly found in modern nuclear reactors, or, more disturbingly, in the aftermath of weapons tests. Natural reactors produce specific, predictable isotopic leftovers. These anomalies don't always match those patterns. Instead, they resemble something more controlled, something more abrupt, something that seems engineered. One particularly strange case emerged from Kazakhstan, where uranium ore formations contain isotope distributions that look suspiciously like the residue left by processed nuclear fuel. The rock layers containing these anomalies are far older than humanity, and the patterns cannot be easily explained by groundwater, volcanic activity, or known natural fission events. They seem to point toward a type of nuclear activity that, at least on paper, should not exist in deep time. It gets stranger. Across multiple continents, thin geological layers contain traces of isotopes like plutonium-239, cesium-135, and strontium-90, isotopes that in nature appear only in minuscule, almost undetectable amounts. In modern times, they are abundant in the aftermath of nuclear explosions and accidents. But in ancient rock, their presence is harder to justify. Some scientists argue contamination from modern industry or nuclear fallout drifting through groundwater. Others insist the samples are far too deeply buried, too thoroughly sealed for modern contamination to explain them. Most of these findings are isolated, debated, and often quietly filed away as anomalies. But taken together, they begin to paint a picture that is difficult to ignore. The Earth's crust contains faint but persistent whispers of nuclear activity that predates us. Some of the most unsettling evidence doesn't come from rocks at all, but from ice. Core samples from Greenland have occasionally shown radioactive traces in layers that, according to dating, formed long before the atomic age. Most researchers assume contamination during drilling or handling, and that remains the simplest solution. But a handful of samples show isotope ratios inconsistent with known contamination pathways. The signatures look like the residues of nuclear fission, but without any plausible modern source. Then there are the sediment cores drawn from the ocean floor. In several cases, scientists found layers that seem to mark sudden ecological collapse, mass die-offs of microorganisms followed by long recovery periods. Embedded in some of those same layers are isotopic spikes that resemble the debris left behind by a high-energy nuclear event. No asteroid impacts correspond to these layers, and volcanic activity, while possible, doesn't fully match the isotopic fingerprint. One layer in the Pacific Ocean is particularly eerie. It coincides with one of the lesser-known extinction pulses of the Cenozoic era. No obvious natural trigger has been found for that die-off, and yet the sediment contains a subtle but distinct elevation of plutonium-like isotopes. If a natural process caused it, it must have been unlike any witnessed elsewhere in Earth's history. And if it wasn't natural, the alternative is far more unsettling. Patterns begin to emerge when you step back. Some isotope spikes occur in narrow concentrated bands, almost like the abrupt signatures left by weapons tests rather than prolonged geological processes. In a few instances, these bands repeat intermittently, separated by thousands or tens of thousands of years, as if whatever caused them occurred in multiple bursts rather than one long event. Nature rarely produces such clean, pulsed patterns. Humans do. Technology does. Nuclear experimentation certainly does. And this is where the myths of ancient cultures suddenly sound less metaphorical. The ancient Indian epic, the Mahabharata, describes weapons that shone brighter than the sun, winds that flattened cities, and survivors whose hair and nails fell out after the blast. For centuries, these descriptions were dismissed as poetic exaggerations or symbolic tales of divine wrath. But read them through the lens of nuclear physics, and the imagery becomes disturbingly familiar. Blinding flashes, radiant heat, residual sickness, contaminated food and water. These details align far too closely with what we've witnessed in modern nuclear disasters. Mainstream historians still interpret such stories symbolically, and they may well be right. But when the Earth itself shows isotopic patterns reminiscent of nuclear events, it becomes harder to shrug off myth entirely. All of this, the ancient isotopes, the unexplained anomalies, the pulsed signatures, the mythological parallels, forces us to ask a deeply uncomfortable question. Could a long-forgotten civilization have reached the level of nuclear technology? Could they have unleashed energies capable of rewriting the minerals beneath their feet, only to vanish so completely that only atoms themselves remember? It is not evidence, but it is a possibility. If humanity were to vanish today, the traces of our nuclear age would outlast our cities, our monuments, even our bones. Tens of thousands of years from now, only faint isotopic fingerprints would remain. Millions of years from now, many of those would still persist. A future species digging in the earth would find those scars without ever knowing the people who left them. And that is the chilling symmetry. When we examine ancient rocks and find isotopic traces that look eerily familiar, we may be glimpsing someone else's scars. The nuclear evidence is only one piece of the puzzle, one layer in the Earth's memory. But it suggests something profound. If technological civilizations existed before us, they did not simply fade. They may have ended violently, catastrophically in fire bright enough to rewrite atoms. And if Earth holds the nuclear shadows of their downfall, it may also hold clues to the materials they created. Materials that, like the isotopes, seem to defy natural explanation. If you want to understand what truly defines our era, what will endure long after our buildings crumble and our monuments dissolve, you shouldn't look at steel towers, or massive dams, or even the satellites orbiting above us. You should look at something far humbler: plastic. Plastic is everywhere. It floats in the ocean, hides in our soil, drifts through the air. Microplastics fall with the rain. They lodge in the organs of animals. They hide in the deepest trenches and in the most remote deserts. Over time, these particles will settle into sediments, compress with sand and organic matter, and fuse into a new kind of rock. Geologists have even given it a name: plastiglomerate, a composite of melted plastic and natural debris, the unmistakable geological signature of human activity. Millions of years from now, when every trace of our civilization has weathered away, plastiglomerate will remain, a fossilized convenience wrapper, a geological testament to chemistry. And if plastic is what we will leave behind, then a haunting question follows. What if we have already uncovered the equivalent traces from civilizations that lived before us? The first hints of this possibility appeared during deep-sea drilling projects. Scientists studying sediment cores from the Pacific and Atlantic discovered something odd in layers that were supposed to be tens of millions of years old. Tiny fragments that looked like polymers, not natural resins or tar-like substances, but long-chain molecular structures more reminiscent of synthetic materials. At first, the reaction was predictable: contamination. Modern plastics from the drilling equipment, the storage tubes, the laboratories, and in many cases that explanation held. Plastic is so pervasive today that avoiding trace contamination is nearly impossible. But then came samples taken from deeper layers, cores pulled from sealed strata, far below the depth where modern contaminants should be able to penetrate. In those rare cases, when the fragments were analysed under microscopes, some displayed ordered internal structures, repeating molecular patterns, chain lengths, and cross-linked bonds that do not match known natural polymers. Some even showed resistance to heat and ultraviolet light greater than many of the plastics we produce today. It is still possible these fragments were brought in by unknown contamination routes, but not every anomaly can be explained that way, and natural substances do not usually mimic the precise uniformity of engineered polymers. So the fragments remain a quiet mystery. Strange materials preserved in stone that should never have existed before humans evolved. And plastics aren't the only anomalies. Metallic spheres and droplets found in ancient rock layers have long raised questions, but even stranger are the isolated fragments of metal alloys found in deep sediments. Fragments with compositions that look engineered rather than natural. Alloys of nickel, iron, chromium, or manganese in ratios closely resembling those used in modern stainless steels or high-temperature industrial materials. Volcanic activity can fuse metals. Meteorites can bring exotic alloys to Earth. But natural processes rarely produce metals that are both alloyed and uniform, with controlled ratios across multiple samples. Alloying is typically a technological process. It requires controlled heat, repeated melting, and intentional mixing. So the presence of alloy-like fragments in sediments millions of years old is difficult to dismiss as random geological coincidence. In Russia, for instance, a set of metallic coils was discovered in deep river sediments. Their age remains debated. Some dating methods suggested they were hundreds of thousands of years old, while skeptics argue they were contaminants washed downstream. But the coils, some smaller than grains of rice, resemble miniature machine components far more closely than anything nature produces. Their exact origin remains unresolved. Another example comes from Romania, where quarry workers unearthed a large piece of aluminum-like metal embedded in sandstone. Analyses suggested the object was composed of nearly pure aluminum, a metal that does not occur in native form on Earth, and must be refined through complex industrial processes. The sandstone layer containing the object was dated to tens of thousands of years old, far earlier than humans were believed to have mastered metal refining. Skeptics have suggested contamination or misidentification of the rock layer, but again, no explanation fully satisfies all the data. These out-of-place artifacts, as they're often called, are usually dismissed by mainstream science, and often for good reason. Many are hoaxes or misinterpretations. Many are the result of sloppy documentation or modern intrusion. But beneath the noise, a handful of legitimate anomalies remain untouched by easy explanations. Small, scattered clues that hint at the possibility, however remote, that others might have tampered with metal long before recorded history began. But even if we set aside the most controversial artifacts, the broader pattern remains the same. Materials that look engineered occasionally appear in geological layers where they do not belong. Sometimes they are microscopic, sometimes they are simply unusual chemical mixtures, but they appear just often enough to spark questions. To understand how significant that is, consider what our own material legacy will look like millions of years from now. Plastics will form sedimentary layers that never existed before. Aluminum, once extremely rare in nature, has become one of the most abundant manufactured materials on Earth. And despite its tendency to corrode, traces of it will remain detectable far into the future. Our alloys, synthetic fibres, composites, electronics, and chemical byproducts will all leave traces that no natural process can fully erase. Now imagine a future geologist examining a thin layer of rock that spans the entire globe. They find microscopic polymer strands that do not resemble any natural substance. They uncover metallic particles in consistent ratios that point to controlled manufacture. They detect chemical residues that require high-temperature processing. Without knowing anything about us, they would immediately conclude that something strange had happened during that era, something industrial, something technological, and that is exactly the position we find ourselves in today when we discover odd fragments in ancient layers. Even if an advanced civilization before us lasted only a few thousand years, a blink in geological time, their most durable materials would still be present. They would be scattered, fragmented, and altered by pressure and chemistry, but not erased entirely. They would survive as hints, echoes, anomalies. The more complex the civilization, the greater the variety of unconventional materials it would create. And the more unusual materials it created, the more signatures it would leave behind. But what if those civilizations did not remain on the surface? What if they expanded outward, into orbit, to the moon, or beyond? If they did, then traces of their existence might lie not only beneath our feet, but above our heads, in places where erosion, weather, and plate tectonics cannot reach. Earth wipes itself clean, space does not, which leads us toward the next arena of clues, the realm beyond the planet, where time moves differently and artifacts can endure far longer than anything left on Earth's surface. When we try to imagine ancient civilizations, we picture them bound to the earth, rooted beside rivers, rising from fertile valleys, shaping landscapes with stone and metal. But if humanity has proven anything, it's that a civilization doesn't stay grounded for long. In only a few generations, we went from horse-drawn carts to rockets, from cave paintings to satellites orbiting the planet. We have already placed our footprint on the moon. We have already scattered probes to the edges of the solar system. If we disappeared tomorrow, some of our most enduring relics would not be on Earth at all. They would be drifting silently above it, or resting on airless worlds where time barely moves. And that simple realization opens a chilling possibility. If an advanced civilization existed long before us, their most enduring traces might not be buried in the soil or hidden in the oceans. They might be waiting in places untouched by erosion, in environments where artifacts can survive for millions, perhaps billions, of years. The first clues that something unusual might linger in Earth's orbit came not from telescopes, but from the earliest days of radio technology. In the mid-20th century, engineers observed strange phenomena known as long-delayed echoes, radio signals broadcast from Earth that returned several seconds later, far longer than normal atmospheric reflection. Most scientists attributed this to ionospheric anomalies, or unknown interactions with Earth's magnetic field. Others speculated about the moon or interplanetary dust clouds reflecting the signals, but a small group wondered something far more provocative. What if an object in space, perhaps something artificial, had caught the signal and bounced it back? The idea was too speculative to gain serious traction, yet it planted a seed. A few decades later, that seed grew into a legend with the story of the so-called Black Knight satellite. It began in the 1960s, when radar installations detected odd objects in polar orbit, an orbit neither the United States nor the Soviet Union had satellites in at the time. Later photos from space missions showed a dark, angular shape drifting above the Earth. NASA identified it as a piece of lost thermal insulation. Yet the object's strange appearance, combined with earlier radar anomalies, fueled speculation that it might be something ancient, something left behind by a forgotten intelligence. Almost certainly, the Black Knight story is a mixture of misidentifications and human imagination. But what makes the tale compelling is how it mirrors what a future species might conclude about us. If humanity vanished tomorrow, many of our satellites would remain in orbit for centuries. Some, in high orbits, would persist for tens of thousands of years. Their solar panels would break, their circuits decay, but their structural forms would remain recognizably artificial to anyone who found them. The truth is simple. Orbit is one of the best places to look for remnants of civilizations that time has erased. But orbit is only the beginning. If a past civilization had developed spaceflight, even to a limited degree, then the moon would be the most natural place to find surviving evidence. Unlike Earth, the moon has no atmosphere, no weather, no oceans, and no tectonic activity. Footprints left by Apollo astronauts will still be there millions of years from now. A metal tool or a fragment of machinery dropped on the lunar surface could survive almost indefinitely, slowly dusted over by micrometeorite impacts but never erased. There have been occasional anomalies, reflective flashes seen from telescopes, unusual geometric formations partially buried under regolith, clusters of glass-like beads arranged in ways that some argue resemble industrial byproducts. The standard explanations point to natural causes, volcanic glass from ancient eruptions, or debris from meteor impacts, and most of the time, those explanations fit. Yet the permanence of the lunar surface makes anyone studying it wonder, if someone else had walked there before us, how would we distinguish their traces from geology unless we looked closely? Space agencies today map the moon in ever-increasing detail, and while nothing unmistakably artificial has been discovered, the search has only begun to scratch the surface, literally. Anything buried even a few meters deep would remain invisible to orbiting probes. Then there is Mars. Billions of years ago, Mars was a world shaped by rivers, lakes, and perhaps even oceans. It had a thicker atmosphere, warmer temperatures, and a potentially habitable environment. If life ever evolved there, and especially if intelligent life emerged, its traces might linger beneath the dust. Early probes like Viking captured images that seemed to hint at artificial shapes, most famously the face on Mars in the Cydonia region. Later missions showed the formation to be a natural mesa sculpted by shadows and erosion, but the fascination it sparked revealed something important. Our minds instinctively search for meaning in the landscapes of other worlds, and yet the question lingers. Mars is covered in dust storms that bury and reveal structures irregularly. In certain meteorites blasted off Mars and later recovered on Earth, microstructures have been found that some scientists once argued resembled fossilized microbes. The debate remains unresolved. If life once flourished there, and if it advanced beyond microbes, its ruins could be buried too deep for current rovers to detect. Windblown sand could easily conceal the remnants of any ancient outpost or settlement. We've barely begun to explore. Beyond Mars lie the asteroids, silent, ancient, metal-rich. To us, they're future mines waiting to be harvested, and indeed, humans are already planning asteroid mining missions. If we succeed, the scars of our extraction will endure on those rocks for ages. Visible grooves, cut surfaces, leftover debris, these would remain long after Earth has forgotten us. Some asteroids already display odd geometric ridges or linear patterns that challenge simple geological explanations. Most are almost certainly natural, formed by rotation, impacts, or fractures. But if someone before us mined asteroids, how would we tell the difference without close inspection? Even more speculative is the possibility that ancient technosignatures might drift freely through the solar system. In 2017, when the object known as Oumuamua passed through our system, its unusual motion sparked debate over whether it was natural or artificial, a light sail, a fragment of technology, or simply a peculiar asteroid. Mainstream science leans toward natural explanations, but the discussion highlighted a growing shift. Scientists are beginning to take the search for non-natural structures seriously, and that includes looking close to home. A handful of researchers now suggest scanning the solar system for lurkers, abandoned probes, dormant machines, or debris left behind by civilizations that might have existed millions of years before us. The reasoning is simple. Earth is a turbulent place. It recycles itself. Space does not. Anything placed on the Moon or in a stable orbit around Earth could survive far longer than anything left on the surface. It would be the perfect place for remnants to hide. All of this raises a profound question. If we truly wanted to leave a lasting legacy, would we build monuments meant to withstand time? Or would we go to space, create machines, and scatter them across the celestial neighborhood? Humanity has already chosen the latter, consciously or not. So if someone else came before us, on Earth, on Mars, or somewhere we never expected, they would likely have done the same. And that leads us to the final, most unsettling idea of all. If civilizations rise and expand into space, only to fall again, then there may be a pattern written not only in rocks and ice, but across the history of intelligence itself. The question is no longer just whether others existed, it's whether the cycle of rise and collapse is woven into the nature of civilization. When we tell the story of humanity, we like to imagine it as a straight upward line, a march from ignorance to knowledge, from darkness to light. We paint ourselves as pioneers, moving ever forward. But the truth of history tells a very different tale. Civilizations rise, flourish, and crumble. Empires expand until they fracture under their own weight. Cultures blaze with brilliance and then vanish into silence. When we zoom out far enough, the pattern is unmistakable. The Romans once believed their empire would last forever. Their roads stretched across continents. Their aqueducts carried water for miles. Their influence seemed invincible, but drought, invasion, corruption, and economic strain slowly eroded the foundations of that world. What was once a superpower dissolved into fragments. The Mayans built cities of stone deep in the jungles, temples aligned with celestial cycles, society structured with remarkable complexity. Yet they too reached a breaking point. Environmental stress, political turmoil, shifting weather patterns, and their civilization receded, swallowed by the forests they once commanded. Angkor, Cahokia, Easter Island, the Harappans. The list goes on. Each was once vibrant, mighty, and confident in its permanence, and each eventually fell. Collapse is not an exception in history, it is the rule. And yet, as devastating as collapse can be, it is rarely the end of humanity's story. Cultures fade, but new ones rise in their place. Knowledge is lost, but sometimes rediscovered. Civilizations burn, but seeds of renewal scatter and grow. The cycle repeats: growth, peak, decline, rebirth. Now stretch that pattern far beyond the span of written memory. Extend it back millions of years, even hundreds of millions. Look not just at human societies, but at life itself. Suddenly the fossil record begins to look eerily familiar. Bursts of innovation followed by sudden crashes, long periods of stability interrupted by catastrophic resets, entire ecosystems flourishing, collapsing and rising again in new forms. The rhythm is unmistakable. The same pulse we see in human civilization echoes throughout the entire history of life. The Cambrian explosion, a sudden surge of complexity, the Great Dying, a near-total collapse of biodiversity, the extinction of the dinosaurs, a sudden clearing that allowed mammals to ascend. Again and again, Earth builds something complex, watches it fall, then builds again from the remnants. If intelligence is a natural product of evolution, If sentience is one of the ways life expresses itself given enough time, then perhaps this cycle extends not just through biology, but through civilizations as well. Perhaps intelligence has risen before, perhaps it reached heights we can scarcely imagine, and then collapsed so completely that only the faintest traces remain. This is the core idea behind the Great Filter, a concept born from the search for extraterrestrial life. The universe is vast, planets number in the billions, life should be everywhere, and yet, silence. No signals, no megastructures, no galactic empires. The Great Filter suggests that somewhere along the path from primitive life to advanced civilization, there is a barrier that most species fail to cross. Some believe the filter lies behind us, that life itself is rare. Others believe it lies ahead, that intelligent civilizations tend to destroy themselves before they can spread among the stars. But what if the filter isn't a single event? What if it is a cycle repeating over and over, both on Earth and across the cosmos? Civilizations rise, they expand, they transform their worlds, and inevitably they encounter forces, ecological, technological, or self-created, that push them past their limits. They collapse, leaving behind only subtle geological fingerprints. Then, given enough time, life tries again. If that is true, then we might not be the first iteration of intelligence on Earth. We might simply be the first to reach this level of awareness, the first to see the cycle clearly enough to name it. That thought is unsettling, but it carries a kind of strange hope. If intelligence has arisen more than once, then consciousness is not a fluke. It is a recurring phenomenon, a pattern woven into the fabric of evolution, a possibility the Earth returns to whenever conditions allow it. But the pattern also contains a warning. Collapse is not random. Collapse follows predictable arcs: overpopulation, resource depletion, environmental destabilization, conflict, loss of resilience. Civilizations grow until they strain the systems that support them. Then those systems break. The fall is often swift and brutal. If an ancient civilization once walked this world, its collapse might have been so complete that even its memory was erased. Climate catastrophe, nuclear war, ecosystem failure. Whatever the cause, the aftermath would have been written into stone, not story. And millions of years later, the remnants of that collapse would look much like the anomalies we're uncovering now. Isotope spikes, strange materials in sediments, abrupt changes in atmospheric chemistry, unexplained extinction pulses. But here is the truly sobering part. We're already leaving the same kinds of marks. In just a few generations, we have pushed carbon dioxide levels to heights unseen in millions of years. We have spread plastics across the globe, from mountain tops to ocean floors. We have generated radioactive isotopes that will remain detectable long after our cities crumble. We have triggered a decline in species so rapid that many scientists now argue a sixth mass extinction is underway. If humanity were to fall tomorrow, future geologists would find a sharp dividing line in the rock, a thin layer filled with synthetic material, heavy metals, industrial chemicals, carbon spikes, nuclear residues, and plastic dust. They would see a sudden disappearance of megafauna. They would see a rapid shift in climate markers, and they would likely assume some dramatic natural event had occurred, not the collapse of a technological species. We would look to them exactly the way ancient extinction events look to us now. So the question is not simply whether others came before us. The deeper question is whether we are about to join them. The pattern is clear. The mirror is unmistakable. What we see in the past may very well be a reflection of our own future. But there is a difference this time. Unlike the Romans or the Mayans or the civilizations erased by deep time, we have something they did not: perspective. We can see the pattern. We can analyze it. we can compare the present to the past in ways no previous culture could, and that awareness may be the one thing that allows us to break the cycle. Perhaps the anomalies in the geological record are not just warnings. Perhaps they are messages from civilizations long gone, not words, not symbols, but scars. They show us what happens when a society grows faster than the system that sustains it. They show us what happens when intelligence becomes powerful enough to reshape a planet, but not wise enough to manage that power. They show us that collapse is possible, and perhaps inevitable, unless something changes. We stand at a crossroads in time, the first species on Earth to understand the consequences of its actions on a planetary scale. We may be repeating a pattern seen countless times before, but awareness offers us a choice. We can continue blindly down the same path, or we can become the exception, the civilization that not only rises but endures. In the end, the question that echoes through deep time is not whether ancient civilizations existed. It is whether future civilizations will look back at us and see a turning point, the moment intelligence broke free from the cycle. And the answer to that question is being written now. We began this journey with something small, tiny metallic spheres sealed in ancient rock, objects so unassuming that most people would walk past them without a second glance. And yet those little curiosities pushed open a door that led far deeper than expected. From the shapes of stones, we followed a trail through fossils, through ice, through the chemistry of the sky itself. We traced isotopes hidden in the earth, strange materials buried in sediments, and whispers of forgotten engineering in the quiet places beyond our planet. Each clue was subtle, none was complete, but together they formed a pattern, a faint outline of a possibility almost too large to face, that we may not be the first civilization to rise on this world, and if others came before us, then the next question is as heavy as it is inevitable: what happened to them? The fossil record pulses with the same rhythm that defines human history, moments of triumph, flashes of brilliance, and then sudden silences. The atmosphere carries scars of events that unfolded long before our species existed, abrupt jumps and collapses that mirror the disruptions we ourselves are now causing. The deepest rocks bear nuclear signatures that should not be there, traces of energies too intense for nature to produce easily. And floating above us, space remains the one place where time does not erase. If anyone reached beyond Earth before us, their ruins may still linger in the dark, waiting to be seen. None of this proves that ancient civilizations existed. The Earth is complex. Nature can mimic intelligence. Contamination can confuse the record. Extraordinary claims demand extraordinary evidence, and so far the evidence remains fragmentary. But the deeper we look, the more the past begins to resemble a mirror, one reflecting not just the mysteries of the ancient time, but the precariousness of our own. Because even if we are the first civilization on Earth, we're not immune to the forces that ended the others. If climate shifts, chemical scars, or technological catastrophes once reset the planet, then those same forces threaten us now. The carbon spike in today's atmosphere looks alarmingly like those frozen in ancient ice. Our plastics, metals, and isotopes are settling into the ground at a pace unmatched in history. We are writing ourselves into the geological record as surely as any civilization that might have come before us. One day, far in the future, another intelligence may examine the rocks and ask the same question we ask now. What happened here? Who changed the sky? Why did the world shift so suddenly? And why did the species responsible disappear? The answer depends on what we choose to do now. If the cycle of rise and collapse is woven into the nature of civilization, then breaking that cycle will be the greatest test any species has ever faced. Not building machines, not splitting atoms, not reaching the moon, but learning how to survive our own power, how to grow without destroying the foundation we stand on, how to recognize the warning signs written into the stone and ice of the worlds before us. The anomalies we've examined may be clues, they may be cautionary tales, they may even be nothing more than misunderstood quirks of nature. But their message is the same: the planet remembers, it keeps its history, and it never forgets those who rose too high, too fast. The greatest mystery isn't whether others came before us. The greatest mystery is whether we'll remain long enough to be remembered at all. If you enjoyed the video, don't forget to leave a like. Thanks for watching, and I'll see you in the next one.